Okay, we have another free response related rates problem, 1982 AB4. We have a ladder 15 feet long leaning against a building so that end X is on level ground, and we'll call that obviously X, or rather its distance, its horizontal distance away from the base of the building will be X, and its vertical height Y above the ground would be small y. And we're told that X is moved away from the building at a constant rate of 1/2 foot per second, giving us dx dt is equal to 1/2 foot per second. Alright, so we're ready to begin. Find the rate in feet per second at which the length OY, which is little y, is changing. And so the rate at which that length is changing would just be dy dt. We want to find that rate when x is equal to 9. So we need a formula to relate dy dt and dx dt, and that would simply be x squared plus y squared is 15 squared. Take the derivative of both sides with respect to t, 2x dt dx dt plus 2y dy dt is equal to 0. Divide through by 2. Now when x is 9 and the hypotenuse is 15, then y will be 12. It's a 3, 4, 5 triangle. And so we have 9. The 2's cancel again, or we divide both sides through by 2. And so x is 9, dx dt is 1/2, y is 12. And we don't know what dy dt is, but that all has to equal 0. So we're going to get 12 dy dt is equal to 9 over 2. So I won't work that out, but you're going to solve that equation for dy dt, and you should get that equals -3/8 feet per second. Second, in part B, we want to find the rate of change in square feet per second of the area of triangle XOY when x is 9 feet from the building. Well, area is just 1/2 base height. In this case, it's going to be 1/2 xy. And if we take the derivative of both sides with respect to t, we can find the rate at which that area is changing. We get dA dt is equal to, we're going to have to use a product rule here, so 1/2 x will be our first function and y will be our second. So we have the first times the derivative of the second plus the second times the derivative of the first, and we're given dx dt originally as 1/2 feet per second, and we know that now dy dt is -3/8 feet per second, and we know x is 9, y is 12, so we just plug everything in. So for the first, we'd get 1/2 times 9 times -3/8, and then 12 times 1/2 times dx dt, which would be another 1/2 there, and this is going to bring us to -27 over 16 plus 12 over 4, which is just 3. So in terms of sixteenths, that would be 48 sixteenths, then minus 27 sixteenths, or 21 sixteenths feet squared per second. And so at that instant in time, the area is actually increasing. And it will start to decrease though as y gets further down. So it'll start off at 0. If the base were pushed all the way up against the wall, you'd have an area of 0, and as the base starts to move away, the area is going to increase. It will increase up to a certain point, and then it will begin to decrease until the top of the ladder is flush against the ground, having 0 area again. And so that's the way that this one works. And that'll do it for this problem.